My name is Antoni. I'm a developer at L2Bit, and I like to talk about layer 2s from time to time. So yeah, normally I start my presentation about asking people.
There is no slides?
Yeah, okay, so maybe slides, yeah. Normally I start my presentation asking people how much of you has even heard about layer 2s, but you know, Tom really did a good job about telling you a bit more, but maybe let's imagine that you were not on this meetup before, and how many of you have ever heard the term layer 2? Raise your hand. So yeah, probably most of the people. Okay, so for those who knew and those who didn't, my presentation will be like this. First, we start with the problem, so why layer 2s were created. Later, we talk a bit about the solution from the bird's eye view, let's say. And later, we'll discuss the details about layer 2s, about risks associated with them. And also, I will introduce what L2Bit is. So, to start my presentation, very important remark at the beginning. It will all be from the perspective of Ethereum. So, you know, there are multiple ecosystems, and maybe layer 2s are different on the different ones. But I just specify the Ethereum one. And mostly, I cannot even talk about different ecosystems. So, yeah, this will be from the perspective of the Ethereum. So, for the sake of this presentation, let's just focus on Ethereum. Okay, so there is this triangle that everyone in crypto are crazy about. So this is the blockchain trilemma, which basically says that you cannot have three of them. And for Ethereum, it is safe to say that we are focusing on security and decentralization. What does it mean? It means that Ethereum is decentralized. It's a bit slow, yeah? Can you hear me? Okay. So it's a bit slow, but what are the advantages? It can run on every PC, so there are low hardware requirements. It allows for the geographical distribution, so even with poor latency, nodes can reach the consensus. Also allows the fast computation and propagation of the block, which basically allows us to reach the consensus very efficiently. Also, it tries to be secure. At the same time, it's a bit expensive, but nodes have to be compensated for the computation, and also this mechanism prevents spam attacks on the network or creating infinite loops on the runtime. So yeah, those small red pills I have shown to you, like there are very, very big green pictures, but also very small red one. So we have low throughput, and it is expensive. And when we look at the top of this triangle, the scalability one, it becomes a bit of a problem. Because what does low throughput mean? We have approximately 12 transactions per second on Ethereum. So if every human being on Earth would like to make a transaction on Ethereum, it will take us 20 years. So basically, for the scalability part, it's a really big problem. Also, it is expensive. You know, imagine just trying to buy a bread with Ethereum, and basically the cost of transaction can be more than the value. And it is mostly determined by the gas price, which can be, you know, which can be way higher when there is, let's say, meme coin mania. So what, maybe we should not buy bread when there is meme coin mania. I don't know. This network should not work like this, right? Okay, so yeah, we see the problem, right? So let's fix Ethereum. What can possibly go wrong? First idea that everyone has. So let's just increase the block space. We'll fit more transactions in the block. But it will take us more time to process this transaction. It will be harder to reach the consensus. Also, the state will grow in size. It will be a big centralization force. So the great thing that we have, this green decentralization, will be at risk. And that is why Ethereum does not try to expand the blocks to the bigger one, because it wants to keep the decentralization. Okay, so that's the first idea. The second is maybe make transactions cheaper, right? So everyone is complaining why my ETH transfer costs like $5. Maybe we should make it like 5 cents. But if we reduce the cost of the transaction, it could become a like DDoS attack vector, or there can be a spam attack on certain contract. So let's say the security, especially the economical security, will be at risk. So that's the first hard to swallow pill. So Ethereum cannot scale, right? It is really hard to swallow, but trust me, it will become better. So yeah, Ethereum is sick, we cannot heal it. So maybe let's just build another blockchain, right? So what can possibly go wrong? So there is this public blockchain paradox as I call it. So the main idea, it is very hard to bootstrap a public blockchain. So it is very hard to start the network similar to Ethereum with the decentralization and security properties of it. And that is because, for example, if you would like to right now start the proof of work network, a miner from one can switch to your network and perform a 51 attack. Or in case of proof of stake, it will take someone very little capital to just outvote the majority and change something for the bad. But you know, people have tried, right? Everyone is trying to bootstrap its own L1. And what can possibly go wrong? So first case, it's Polygon, that you are not open to everyone, you are just open to a certain amount of people, but it is not that decentralized, right? So only few people decide what will happen with the network, and it is not yet sure who holds the keys. It can become a really big mess, and I don't think whether we want blockchains to go in this direction. The second case is you can create a blockchain which is super fast, but it will have like a very high hardware requirement. So you have to run it on the like servers, like with petabytes of RAM or whatever, and it can lose the consensus from time to time, and the outage can like stop the network from functioning. So the second hard to swallow pill is Ethereum is here to stay. I need to drink. Okay, it is really hard to swallow pill. Because you cannot fix Ethereum, but it is here to stay. So what should we do, right? Maybe we should just use Ethereum. It has low throughput, but it is decentralized. It is expensive, but it's secure. Right. So maybe let's make Ethereum great again. Okay, we'll introduce the scalability. We'll do it. We can do it. No. It's hard to swallow, but we cannot solve the scalability of Ethereum on its own. We will try to build another blockchain, but this time we'll connect it with Ethereum. And that is basically the idea of layer 2. So you move some operations off the chain, but you inherit the properties of Ethereum. So everything that was green before, you've seen the decentralization, the security, it still in theory becomes green, but also you are gaining the scalability. And in a very basic example, you can see that the cooperation is like this. Layer 1 needs layer 2, and layer 2 also needs layer 1. So it became, there were a few ideas in the beginning. The first one is Lightning Network. In the beginning, it was on Bitcoin. Later, the company Raiden Network tried to deploy it on Ethereum. But obviously, you probably never heard about this one, so it never really panned out. Also, there was an idea about the Plasma and OMG network, but basically it's not working anymore, and I don't think they are even developing this project anymore. Okay, so then came a time that someone came up with a great idea for layer 2s. And the thing that we currently call layer 2 is a rollup. So you can think of a rollup as a blockchain that posts their blocks to another blockchain and inherit the consensus and data availability of that blockchain. So this consensus and data availability is the green things, the green properties that we really want. That's why we are using Ethereum. But you know, everyone wants to use Ethereum, but it's too expensive. So that is why the main idea is just to move to layer 2s. And in the very easy mental model, you can think about is that layer 2 is just packing multiple blocks of layer 2 into one layer 1 block. But it's just a really high overview. But stay with me, we'll get more into the details. Okay, so you take a lot of blocks, you put it into L1. So you can fit more in the one L1 block space, but at the same time you preserve those properties of Ethereum. another mental model. So you can think about a blockchain of like a train. So without those balloons are layer 2s, you'll have those very heavy elements in this wagon. But with balloons, you can basically fit heavier ones into the train. That is also another way if you want to grasp it. But after we have this very basic image of what layer 2 is, so that we are packing something or we make something lighter so we can like feel more, let's go more into the details. So I created the visual guide for how to roll it up. And basically, what this rollup even is. Because for me in the beginning it was not really clear. I would say that rollup system consists of two things. The first part is Ethereum, and there is a smart contract that is deployed on Ethereum, and it stores the state of the rollup. And the other part is a rollup itself. So here are the nodes, they are running the software, very often very similar to the Ethereum one, but they are listening to the Ethereum, what's happening there on the bridge contract or any other contract that they specify, and they, from time to time, post the transaction here to update the state. And here you can see that there are balances, their state is oversimplification. So let's imagine you are an Ethereum maxi, right? And you want to use this rollup because you really love Ethereum. You want to use it, but it's too expensive. So you decide to use this new super good rollup. You go to the L1 bridge, you deposit your money, and this bridge emits an event which nodes on layer 2 listen, and later they update their own state on layer 2. It is a very big oversimplification, but I want you to just understand that it's not like they are super connected, but they are like layer 2 is listening to layer 1 at some point. Okay, and later what's happening is now Maxi is operating on layer 2, so he can do like DeFi magic, double his money, triple his money. He can spend a lot of gas, but this gas will be cheaper than doing it on layer 1. And what rollup does, it's from time to time, it just updates the state on layer 1. So you see that Maxi now has 100 here and 100 here. And going more into the details, what this rollup even stores is that it posts the blocks, so the input data, and also new state root after the computation. So we can think about it that layer 2 is just moving computation of the chain, and you just post the data. And withdraw is, as you can probably think of, very similar, that you just say that you want to withdraw, and the rollup is also updating the state. Like, this is a very big oversimplification, like most of the rollups don't work this way, but it's just a very important mental model, just to grasp it in the beginning. And as we can see, Maxi was able to deposit 1 Ether, make a lot of transactions on layer 2, which were way cheaper, and later withdraw this money. So for him, it was good to interact with the rollup because it was way cheaper. And at the same time, he was still as secure as using Ethereum, at least in theory, if the system was implemented correctly. So probably that's the scalability that we want, right? We can use something that feels like Ethereum, that works like Ethereum, but it's cheaper and more scalable. And even more detailed explanation for those of you who are like the most interested about layer 2s. In the plain words, in plain English, it's just you give inputs to someone else and you let them perform the computation of the chain. Okay, so you do the computations of the chain and you store those inputs on the data availability. In many cases, just you store them on Ethereum. Later, you make someone else to prove that the computation was correct. So after he posts this L2 state root, you have to make him prove that the computation on the inputs were correct. And we'll get to the point of the proving, but for now, let's just assume that you have to prove that the computations were correct. So you just store the inputs, and later you make someone to prove the computations. So we ensure their validity. And at the end, the idea is to ensure that verifying the proof is cheaper than verifying the original computation. So your rollup should be economically sustainable. And that is what really brings scalability to Ethereum. What makes rollup scale is that this simple equation is like DA cost, so they, like posting inputs plus proving the proving cost is smaller than just the original computation. So you can make a lot of transaction on the rollup, but still inherit the properties of Ethereum. So basically, cost of this one and cost of this one has to be like smaller than if you just interact with Ethereum here. Okay, and the summary at the end. Let me grab a water. It's that a rollup posts their block on another blockchain, okay, inherit the consensus and DA from that blockchain, have a special contract that maintains the state root, and it should be trustless, permissionless, and censorship resistant. So what does it mean? It means that everyone can run their L2 node, and everyone can post the state, and if the state is not correct, we can make a dispute, or you cannot even post the incorrect state. But you will soon learn that it is not always the case, and not all the layer 2s currently are working this way. And the very, very basic idea is that it provides the base layer user, that someone that really likes Ethereum, that wants to use some technology like this, with the cheaper transactions, but it still preserves the properties of Ethereum, and it grows the Ethereum ecosystem anyway. Yeah. Even this random user of Twitter called Vitalik Buterin, he even wrote a blog post that there is a rollup-centric Ethereum roadmap, and that is the way the Ethereum thinks to scale. So even Ethereum Foundation is really propping this up. And what is really interesting, in my opinion, is that Ethereum has a market approach to rollups. So basically, there is no official Ethereum rollup. So for example, they can create it like EIP rollup and create just a official Ethereum rollup that we should all use. Instead, many companies compete to create the best solution. And it is also very interesting that currently we are living in such a times that it's even feasible to run such a rollup, because you have to have the certain user base to make it feasible to post the state and everything, because there are some fixed costs that, for example, if only 3 people try to run the rollup, it won't be feasible. You have to have a lot of user base to just run the rollup. So that's a very interesting time to be in. But this is an open market in early stages. So you have to remember that the technology is still in its infancy. There are bugs, there are hacks, and whatever you name it, only bad things. And nothing prevents bad actors from entering. So basically, anyone can create a rollup. Anyone can try to scam you into depositing your money on layer 1 contract. So users are exposed to a lot of risks. And that is where L2Bit is coming. L2Bit is a research and analytics webpage where we just have all the projects currently deployed on layer 1 on Ethereum. We present some statistics about them, so maybe total value locked, how much is basically to hack for the hacker, or how much is locked for the DeFi. The activity, so how many transactions are happening, and what is interesting is that for almost half a year now, there is more activity on layer 2s than on Ethereum, so I think it's appreciating slowly, but it's getting there. But what I think is the most interesting about L2Bit is the risk analysis. So basically, we looked at every rollup, and we came up with this, let's say, risk matrix to say about the risk of every rollup. And basically, you can see what it means to use Arbitrum, what it means to use OP mainnet, what are the risks that you are, as a user, exposed to, and what you have to have in mind if you store there a lot of money. And yeah. And after that, I will try to go through every of this column and just try to slowly get you into our risk framework. So maybe you will see some, let's say, correlations with what I talked about before, right now. So the first idea is the state validation, right? You remember this L1 contract that you have to prove the computation were correct. So it happens that there are two ways of doing it. There are optimistic rollups, and there are zero-knowledge rollups. Maybe we'll not get into many details, but the very brief example is that in optimistic rollup, you just optimistically assume that everyone is telling the truth, and only someone can go to the judge, and the judge, so the layer 1 contract, will state whether this new state update was correct or not. But in the case of zero knowledge, as you can see now, Ethereum is like verifying ZK proof. So it means that you cannot even post the new state root, which is incorrect. But it's way more complex. Excuse me, we'll not get into more details because I think it's really hard to talk about it from the best principles. But here you can see the L2 bit, part of the L2 bit. So basically you can see that we assume that some projects have. Oh, maybe let's start with the black one. So there is a ZK proof. So everything is, let's say, almost safe. That there is a contract that is making the state correct on layer 1, but some systems just have it in development. So if you are using, let's say, Optimism, you cannot even be sure that the new state update was correct. And this is something you as a user have to be aware of. The second one is data availability. So I've shown you that we have to post the blocks on layer 1, and it happens that it is a rollup. But there are some scalability solutions called Validium, which do not post it. They just post it to the server, the third-party server, and it is called Data Availability Committee. So basically, few servers have to sign that they have the data, but what basically means is that this data is somewhere else, and you have to trust someone that is there. And it's really not good for us. It's a yellow one. We stated, like, basically you can think about it. What will happen if your rollup will shut down? If your rollup will shut down, in the case of on-chain data, you can reconstruct it from the Ethereum state. But in the case of Data Availability Committee, you have to ask Data Availability Committee for the data. And that is a thing that you should consider when using such a rollup. Also, there is a risk called upgradability. So can L1 smart contract be upgraded? And it is currently a big, let's say, a big issue, because at one point we want to have immutable contracts, so we don't want to upgrade them. We want to have this immutability of Ethereum, but just look at this picture. It's this picture of Arbitrum, and it has a lot of contracts. And to be honest, deploying it and making sure it works, it's really hard. And even if one of these contract is malfunctioning, you have to probably redeploy everything. So what happens in most cases is that there is a delay on which you can update your contract. So the user, if he is not good with the upgrade, he can just move away from the rollup. But some contracts are just instantly upgradable. So it means if you have the money on layer 1 contract, someone can just press the button and drain all your funds. And it's really important to know that if you store extensive amounts of money on any of those contracts. So remember the website and check the risk there. Also, there is a sequencer and proposer. So I have lied to you a bit that we just do it in the one step, but what most rollups do is that they have two roles. One role is responsible for just posting the blocks, and the other one is responsible for posting the new state root. And basically what it means is that there is a sequencer who orders the transaction and posts them to L1. So you have to talk to the sequencer, and he will decide which transaction in which order will happen. And that is exactly what we show here. So here you have to think about what will happen if the sequencer will go down. So your rollup totally shuts down. You have your 100 ETH there, and what can you do? In the case of force via L1, you can just call the L1 smart contract and withdraw your money from the bridge. But in many cases, there is just no mechanism. So if the team shuts down, or I don't know, whatever happens, you cannot withdraw your money. So that is also a very important risk to know about. And the last one is a proposer, so someone who updates the state. And it's, let's say, very similar to the proposer one. So you have to also think about what will happen if he just goes down and he's not responding. So in many cases, you just cannot withdraw your money, so you cannot update the state. You earned 100 there, but he will not update your state, you cannot withdraw. But in some cases, you can just use escape hatch, and you can self-propose the new state, so you can post it. And that is the main idea. We also create this small handy risk rosette that just gives you all the risks in one place, so you can quickly gather and take a look what are the differences between certain projects. So I think it comes quite in handy. You can also find it, maybe not here, but also on our website you can find it in the main page. And that's basically it. That's the idea. So you have layer 2s. They are scaling. They are trying to scale Ethereum. They are trying to still have those properties of Ethereum, but at the same time, you see there are a lot of risks, and that is why I think every user, before just trying to use one of the systems, should just know the risks, that sometimes your money is really at risk if something goes wrong. So that is basically it. Maybe any questions regarding the topic? Yeah.
I can speak straight to the mic there. Oh, yeah, thank you. Yeah, do you hear me? Yeah. So first of all, my name is Vladimir. Thank you very much for presentation. It's really nice, and L2Bit resource is also looking absolutely great. It's really useful thing. I have a couple of questions. The main one I think is caused with the point that I have not following the Ethereum infrastructure updates for some time, maybe for a year or 1.5. And the first question I see that, like, when we talk about scaling solutions, is what has happened to Ethereum 2.0. That was like, there was a lot of talks about that there should be a solution for scaling, and it is not clear for me. Actually, do we talk now about Ethereum 2.0, or it is still good old first version of Ethereum?
So you mean whether the 2.0 introduced the scalability, right?
Yeah, because a lot of discussions was before mainnet of Ethereum 2.0 was launched. I guess it was maybe a year ago, about solutions to scale.
Yeah, but mostly Ethereum 2.0 was just the upgrade of the consensus mechanism, and it did not introduce any scalability. Let's say there were a lot of misconceptions about this one, but literally after the update, the fees stayed the same mostly, and the throughput is almost the same. So basically, the problems still exist about this one, and rollups are still needed.
So does it mean that this problem exists for both versions of Ethereum?
Yeah.
Both first, yeah, I got it. Thank you. And if it's okay, I would like to ask one more question. Like, again, from me as a person who is not really deeply into the context of, like, in technical details how current ecosystem of blockchain works, like, it looks to me that if we have some kind of another blockchain as a layer 2 solution that could perform some transactions and prove that it was done correctly, then two questions coming out from this idea. The first one is that why do we need Ethereum at all? Like, we have already blockchain that can perform transactions and prove that they are valid. What else do we need? And the second one, what allows layer 2 solutions to perform transactions that cheap, much cheaper than Ethereum? So I guess two questions should be somehow related, and I guess that I missed something.
So just to sum up in the beginning, your first question was why Ethereum at all? Why should use Ethereum, right?
Yeah. Why do we need Ethereum if we something?
So the basic idea and the thing I wanted to talk in the beginning is that is just everything from the perspective of Ethereum. So there is a certain network of Ethereum. People believe in it. People use it. People like those properties, and they want to use it, but it's not scalable. So that's why the L2 solutions are created. But basically, nothing prevents people from just creating another layer 1 and use it. It's just this network effect of Ethereum, and that people want to stay on Ethereum, on something similar to Ethereum. And that's the idea of the rollups.
But if you take some layer 2 solution and use it just by its own without Ethereum, like just believing
it's possible.
proofs, so it should work, right?
Yeah, it's all just to the users.
Okay, thank you.
Can I add something? So the idea here is that these networks are basically, so those blockchains, the sequencer is just one computer, right? So if we used it on its own, it wouldn't inherit any of the security and any of the security properties of Ethereum, right? It's only safe because it inherits them, right? It doesn't have them on its own, right? So right now the rollup-centric Ethereum roadmap says that people will not use L1 to transact, to do things on L1, right? That user-focused networks would be L2s, but the L1 basically provides the data availability. So we know the data availability, and if something goes wrong with an L2, we can use L1 because we are sure that if we transact on L1, the sequencer will not censor us, or we can, for example, we can just withdraw to L1 if something goes bad, right? So basically, those L2 networks work like a charm only because Ethereum is under them.
So it looks like if we trust, if we say that we trust to proof of layer 2 blockchain, we trust it, but not as much as Ethereum, and this is the main difference. Is it correct?
Yeah, and also there's also a very important factor that we have to take into account, that currently there is a lot of volume, a lot of value locked into Ethereum. And what those rollups claim to do is that they create risk-minimized bridges. So you can bridge this value to other layer 2, and you can still have it on layer 1. You are not putting it into Solana, you are not putting it into Polygon, you are still having it on Ethereum. It is super safe on this risk-minimized bridge, in theory, okay? And you are using the layer 2. So I think currently the biggest selling point of layer 2s is just those risk-minimized bridges, that you can just bridge your value to other layer 2, use it as this guy, this Maxi was using it, but you are still having it on layer 1. And that is basically the most basic idea about layer 2s, that you have a place where your money is safe and you can use the other network, but if this network shuts down, you can always exit safely and your funds are stored, right?
Yeah, thank you. And also, does it make sense that the point is that transactions are cheap is reached because like there is smaller amount of value locked in these layer 2 solutions? So this is it the main reason why transactions are much cheaper?
No, it's just they are different networks than Ethereum. So there is less nodes, but basically it's just you have other environment that everything is running. So they can set the transaction fees to be smaller, let's say. Maybe Adrian can elaborate.
Yeah, thanks. Yeah, hi, I'm Adrian from same team, so we can also. So the transactions are cheaper because the computation, the really expensive part that is really the expensive part on Ethereum, right? Because every single node to reach consensus need to perform these operations. You send one transaction on Uniswap or somewhere, and every single node, every validator needs to execute it. That's why it's expensive. And we move the execution out from Ethereum, which means that Ethereum nodes don't really execute these transactions. And maybe a single node on L2, like this sequencer, executes it, or for example in Starknet it's the prover, but there can be just one computer that executes it. That's why it's cheap, right? It's really cheap to do this in one place. So we move the execution of Ethereum, and we only prove to Ethereum that we did the execution in one of the two ways, right? So that's why it can be much cheaper. And to go back to the question that Michał already replied to, is that the consensus, right? Reaching consensus is one of the most difficult things, right? The Bitcoin came up as a new thing because they figured out how to have a consensus, distributed consensus of who has how much money, because everything else pretty much was done, right? But how do you reach consensus in distributed manner is extremely expensive and extremely difficult. And rollups don't have any consensus. They only actually have consensus because once they have something, then they put it on Ethereum, and the one that Ethereum decides is the one, then it is that then this is the valid one, right? So rollups cannot exist without Ethereum, right? They cannot just say, okay, let's ditch Ethereum and we can work, because there's no consensus to be reached without Ethereum. So that's another point. And going back to your very initial question about Ethereum 2.0, because I was actually following this as well. So there were ideas, right, that Vitalik and the Ethereum Foundation had at the beginning, that there would be some data sharding and like multiple shards. They wanted to do the quadratic sharding for the data and for computation. So there was idea that some parts of the network do some smart contracts and some parts of the network do execute others, etc. There was this whole idea. But once they realized that the rollups are the way to go, the idea of Ethereum 2.0 has been ditched. There's no idea of Ethereum 2.0. It will never happen, ever, right? That's the current approach. They actually changed the consensus, which was called a merge, because it was first called Ethereum 2.0 as like the smallest part without any data sharding. It was called the merge, actually, to switch from proof of work to proof of stake, which is the consensus mechanism. And well, not exactly, but yeah, more or less. So now the approach is that Ethereum will stay as it is. It will try to add some additional features to make rollups cheaper still, right? For example, now there is something called proto-dunk sharding, which, so actually that's a bit different, which means that there will be a dedicated place in the blocks of Ethereum coming, which is a temporary storage for data, which means that rollups, rather than put the data onto Ethereum, they can put into this temporary space on the blocks, which is much cheaper because it's only temporary, just for the time being, so that everyone can verify that the rollup was fine. But the whole idea is that Ethereum will stay as it is with small additions, which will make L2s and rollups scale it outside, right? So that's my understanding.
Yeah, to sum up, the very basic idea is that on Ethereum, just see the inputs. So let's say 2 plus 2, and later you just post 4 to Ethereum. And every computation, this computation was really simple, but imagine that you have to read few storage slots, that you have to write something to storage slot. It costs a lot of gas. And basically all of that is happening somewhere other else, and just output is stored here. And that is why it scales. Thanks.
Okay. Sorry. One more question.
I just opened L2Bit and saw that you not mentioned about stage of maturity of product.
Yeah, it's
or I miss it.
It's our fairly recent feature that we've added, and it focuses on the, let's say, stage of the development, because you remember that I've told you that not many systems currently are working as they should be, right? So in the perfect world, it will just be all permissionless, open to anyone, without the upgrades. But you know, there are some systems that are more developed than the other. Some are more safe than the others. And just this idea of a stage is like, let's say, we just show how far away are they on the roadmap to scaling in the, let's say, Ethereum way. It is not about security at all. It's just about this roadmap that we want to decentralize, that we want to have it economically secure, but not about, you know, hacks or whatever. We are just doing the work on, let's say, a roadmap for every rollup.
And do you mean a roadmap of a product or roadmap that you saw in your team?
If you go to our website, there are requirements for this one, and we have like requirement for every stage to be passed. So, for example, if you want, you have to expand the stage button, and yeah.
Oh, I
Yeah.
see. Okay, thank you.
And you see all the requirements. So for example, stage 1 rollup can be upgraded immediately. Let's say you can, your money can be stolen, but the stage 2 rollup, has a very long delay. So it means that it's more secure. And that is our basic idea, that stage 2 rollup is more of a rollup than stage 0.
Okay, thank you.
You're welcome.
Is there any questions? Okay.
So hi, my name is Michał Posłuszny, and one question came up to my mind regarding the gas fee. So we already know that this is cheaper because we only need to validate proof and not do the whole computation. But is there a chance that the L2 layer gas fees will get higher and higher, and we will need to do something like layer 3?
Yeah, it's an open question really, and no one really knows the answer. But basically, if we just create layer 2 that is very similar to layer 1, so a lot of nodes have to redo this computation from layer 1, basically we could end up with the same thing. So I think right now the idea is that there will be many rollups, and it will just span across the ecosystem. But basically, if we just want to create one rollup for Ethereum, it will be very hard. Or maybe Adrian can elaborate.
Okay, and does this Stark system, which provides single node for computation, could improve the situation or change it somehow?
Can you repeat the question? Like, you mean there is one node?
Yes, like it was mentioned on the previous presentation that there is the one that focused on computing the proof.
Yeah. So you mean that you can make the proof and verifying is way cheaper, right? So you can spread this fixed cost on many more.
Yeah.
So currently the idea is that zk rollups will scale more because this fixed cost, if there is certain amount of users, it scales better. But to be honest, it will be determined in the future. It is hard to right now say which will scale more. But answering your first question is that, yeah, L2 can still become really expensive if a lot of people start using it.
Yeah, thank you.
There is no magic included.
Yeah, actually, there's one interesting thing when you think about this kind of layer 2s is that the more users they have, the cheaper the gas becomes. And this is because the layer 2 pays the gas cost to put stuff on Ethereum. And the stuff that they put in Ethereum is very small compared to the whole computation that happened on L2. But if you have just one person doing stuff on L2, that one person will have to cover in the cost of transactions the whole cost of putting on Ethereum. But if you have 10 people, the cost of putting on Ethereum kind of spreads into these 10 people, and it actually goes down for a long time until it reaches some other extremes. Like, for example, actually the amount of data is so big that it doesn't fit in a block on Ethereum, and then suddenly you reach some other limits. So in theory, yes, you're right, the gas cost will ultimately begin to rise once you get some other limits. But the nice thing is that at the beginning, the more users you have, the cheaper the gas becomes. So yeah, it becomes much more complex if you look further into it.
Okay. Okay, so we have time for one last question here. So, please.
Okay, my name is Bartek, and I've got a question. As far as I'm concerned, an alternative to rollups are parachains. Yes?
What do you mean exactly by parachain?
Parachains, like, for example, Kusama or Polkadot, overall alternative to rollups to solve scalability problem.
I'm not really into, but you can ask the question.
Okay, so it might not be a valid question, because I wanted to ask if rollups actually has advantages over parachains, considering that you talked about scam risks.
That's a really hard question, because probably the idea of Polkadot is that you can somehow connect Ethereum to it, right?
Yeah, I guess.
So if they are able to pull it off, but to be honest, I'm not really an expert on that one and have never thought about it. Maybe Adrian?
Yeah, I would say that there is a major advantage, in my opinion, meaning that a well-constructed rollup, which if you look at L2Bit page, there are only 2 right now, which are not even have valid computation. So most of them don't meet this, but we know how to do it. It's just complex. Is that if anyone on L2, for example, let's say you put your money on Arbitrum or Optimism once they reach the final stage. If you put the money there and then they all get arrested, everything is closed down, they burn down their servers, everything happens, you can still, by interacting just with Ethereum, get all your money back.
Okay.
And with parachains, you obviously can do it. If they stop the parachain, or like sidechain, what you call it, then your money is gone. And with L2s, you are still protected by Ethereum. And if everything goes down, you can still, just by interacting with Ethereum, get the money out.
Okay,
so I think that's the most important one.
Okay, so thank you, Antoni, for your
Okay,
presentation.
so also for more interested people, there is an extra slide that you can find under this link, and also it is to my social media. So thanks everyone once again.